हॅलो एव्हरीवन. myself Mr. बुलाके भाऊ अशोक, रयत शिक्षण संस्था आबासाहेब मराठी आर्ट्स अँड न्यू कॉमर्स सायन्स कॉलेज राजापूर. Today's lectures we are going to discuss the topic organometallics. In these topics, the last lectures we have seen some reactions of organolithium compounds like the reactions with cyanides, reaction with carbon dioxides, or the reactions with the alkyl halides, carbonyl compounds. Now, the today's lectures we have see some applications of these organolithium compounds. So, first applications are here the preparation of di-N-butyl ketone, N-dibutyl ketone. In first reactions, here the N-butyl lithium are treated with this carbon dioxide. Then what happens? This butyl group act as a nucleophile, and this butyl group which attack on this carbonyl carbon and to get these type of intermediates. And these intermediate which are treated with another molecules of N-butyl lithium. Then what happens? This butyl act as a nucleophile, is attack on the second carbonyl carbon, and to get these new intermediates are formed. Then after formation of such type of intermediate, we see in this intermediate the two oxygens are there. This oxygen and this oxygens having a negative charge. So this is a negative charge, this is also a negative charge. And then after formation of such a type of intermediate, then what happens? These intermediates are treated with acid hydrolysis with water. Then what happens? This O minus, both O minus, it will be converted into OH by taking the proton from this H, H3O plus, and to get convert into OH, it is also OH. So both having OH, and then after formation of this OH, after repluxing of such reactions, then what happens? The water molecules will be replaced, like this OH having a one H and this OH. So OH and this H, the water molecules will be it will be replaced, and to get the new ketone having the name is N-butyl ketone. Alright. So di N-butyl ketone. Why it is a di? Because in these molecules it is having the one butyl group, it is the second butyl group, so it is a di, and it is straight chain ketone, and therefore it is name is a di N butyl ketone. So we are prepared by using this reaction. Second applications, we are see that the preparation of preparation of acetone. In these examples, we are prepared by using this method to prepare acetone like the above reaction. This methyl group acts as a nucleophile, and this methyl group is attack on carbonyl carbon and to form such type of intermediates. And these intermediates are treated with another molecules of alkyl lithium like methyl lithium. Then what happens? So these another molecules of methyl lithium are treated. Then this methyl is attack on this carbonyl carbon and to get such type of intermediate having the both oxygen as the negative charge. Then these intermediates are treated with the acid hydrolysis of the water. Then what happens? This O minus and this O minus pick up proton from this water and to get the OH. It is here OH, it is also here OH. So both OH having the one of this hydrogen and this the OH. So one of the water molecules it will get replaced and to form the final product is acetone. So this is the one of the OH and this H. So we form the carbon oxygen double bond is here and replace this OH. So this OH and H by replacing water molecules and to get the product is a acetone. Next applications we are see the preparation of acetophenone. So these methods are used to prepare acetophenone like this benzoic acid are treated with the methyl lithium. Then what happens? The methyl is act as a nucleophile is attack on this carbonyl carbon and to get this type of intermediates. Then after formation of such a type of intermediate, then what happens? The another molecules of methyl lithium we have add in this intermediate. Then this methyl act as a good nucleophile and is attack on this carbonyl carbon and to form the another intermediate. And these intermediates having a oxygen carries negative charge is here and oxygen carries negative charge is here. So both oxygen is the negative charge and these intermediates can be treated with acid hydrolysis. Uh, these intermediates can treat with acid hydrolysis with water. Then what happens? These both O minus, it is also O minus, it is also O minus are converted to OH, it is also OH. Then after formation of both OH, what happens? The minus water molecules are replaced and to get the final product is acetophenone. But in these reactions, one step are very important. You know that this aromatic benzoic acid, aromatic acid, which are very less reactive, and therefore we are prepared the acetophenone by using other reactions like the Grignard reactions, which are not possible for the preparation of acetophenone, but this alkyl lithium, by using this method we are easily prepared this type of acetophenone. So how will you done these reactions? These reactions which are the methyl lithium attack on carbonyl carbon and this formation of intermediates, and after formation of intermediate the oxygen having negative charge, lithium carries positive charge. Another molecules of methyl is attack is here. So methyl is that side and to form the new O lithium bond is here. And after formation of such a type of intermediate can treat with water to get OH is here. And after removal of these water molecules to get your final product is acetophenone. Now we have see the next reactions like reactions with epoxide. You know that organolithium compounds we are add to epoxide ring, hence opening can be done. The resulting product which on hydrolysis to gives primary alcohol having two additional carbon atoms. Similar reaction can be done in the Grignard reactions. So we have firstly see the general reactions with epoxide. This is alkyl lithium are treat with this containing the epoxide like ethylene oxide. Then what happens? These alkyl like a capital R act as a nucleophile, and this nucleophile is attack on this carbon. Then what happens? Open the ring on that side and to get the new intermediates having the O minus and lithium plus, right? If this alkyl group is attack on this carbon, then what happens? The opening of the ring can be done on this side, this O minus are on that side, that is the left hand side. So any one side of this epoxide ring can be break. After breaking of this epoxide ring to forming such a type of intermediate, and these intermediate which on has acid hydrolysis with water to get the corresponding alcohol having a primary alcohol. So this is the final product is primary alcohol in presence of the epoxide are take place. Let's we have see another reactions like the phenyllithium, and these phenyllithium are treated with the ethylene oxide. Then what happens? This phenyl ring act as a nucleophile and which is attack on this carbon. Then the breaking of this bond can take place. After breaking, the epoxide ring can open on that side in such a way that this phenyl ring is attached to this carbon, and this phenyl ring CH2 on that side, that is right hand side, O lithium. And then after formation of such intermediates are treated with acid hydrolysis, then what happens? These intermediate having a O minus are pick up proton from this acid and to convert into these alcohol. So what is the name of this alcohol? Are the 2-phenyl ethanol, right? This is a functional group is here. So numbering is given the first this carbon and second this carbon. So second position having the phenyl group, therefore 2-phenyl, and parent name is ethanol. So 2-phenyl ethanol as the final product. Another reactions we have see like butyl lithium are treated with this to open the ring on this side and to form these intermediates, and these intermediates which on hydrolysis with water to get the corresponding alcohol as the product. Similarly, these ethyl lithium are treated with ethylene oxide. Then what happens? The ethyl group acts as a nucleophile and is attack on this carbon, breaking of this bond and open the ring on that side to form such a type of intermediate. After formation of these intermediate are treated with the acid hydrolysis with water, how will you get the final product? So this O minus take the proton from the product.